Let's find out how we can use the MathScript node as a technique for generating a customized array. The array I would like is called X, and it has n samples, and at the midpoint of n over 2 samples I'd like it to reach its maximum and then taper off back towards 0. So we can think of creating now a customized node for LabVIEW. This is again using the MathScript node technique, and it can accept a value n as input and then produce an array as an output. Now the way this node works is the interior of the node is actually text, and this is called MathScript syntax, and one of the functions available in MathScript is called linspace, which says generate linearly spaced values between, say, 0 and 1. That's my first two arguments, and I need n over 2 samples total. Then I can make a second call to linspace, so my values run from 1 back down to 0, and also I have n over 2 samples. I enclose these in square brackets to make a vector, and I assign that to the value x, which is my output. Now the best way to develop a brand new MathScript node is to first use the interactive MathScript window. This makes it easier to debug and test your MathScript code, and then once you have it operational, then you can actually put it into the MathScript node back in your block diagram. So I'll just type in the same expression that I developed earlier. And in this case it all fits on one line, so I don't need to use the ellipsis as a line continuation. Also, I just typed in a specific value of n being 20, so that way we could see the results being generated by x. And let's just confirm by plotting x that it makes some sense. So perhaps we could do a little more work on this to deal with situations of n being even versus n being odd and so on. But for now, for this illustration, I'll just run with the code that we have. Now, before I leave this section, I wanted to point out that if you type help classes, then you can get an index of all of the various function categories that are available inside MathScript. If you then type a specific function name, then you can get the detailed help on that. And really, this is about the only way that you can find out some details on MathScript syntax, because once you're in the block diagram environment, you have to know what you're doing. So I'm going to go ahead and copy that text so I can then paste it into my MathScript node shortly. So I'll begin by creating a blank VI. And let's look at the front panel and the block diagram simultaneously. Under Structures, I will then place the MathScript node, which has the characteristic blue highlight. At this point, I simply type in the text, and my input is capital N, and my output is lowercase x. Incidentally, it might be good for documentation purposes to just insert a comment explaining what this code is supposed to do. So comments are indicated by a % symbol. Let me just spend a little time resizing here, and then we'll go ahead and say add input, and that was a right click in order to get at that context menu. We'll add the output. Now these are case sensitive, so they do have to match what you've typed in your code directly. Alright, let's do a right click and we'll select Create Control for our input. Let's scoot this down where you can see it a little better. And then right click again and Create Indicator. And that will show us what's going on with the output. So let me try plugging in the same value we used in the interactive window. So I'll put in n as 20 and we'll run that. And it says x is 0. Also, if you look carefully, you'll notice that the indicator x is actually a scalar. So we have to actually right-click on that MathScript output node, or output terminal, excuse me, and set that to an array type. Now that means we also have to then modify or change out the indicator. So let me just delete that and create a new indicator, which we now see as an array type. Run the VI again, and sure enough we can see all the values that are being generated for our triangle shaped array. Let me also switch that over to a plot, and sure enough that looks like exactly what we need.